Okay, so you had some homework problems. This says find the slope of a curve of y equals x squared minus 2x minus 4 at the point 2, -4, finding the limit of the secant slopes through the point P. Okay, so remember we were looking at curves and we were trying to find the slope of a secant line, and that basically was through a point and a point that was really, really close to the point that we're trying to actually find the instantaneous rate of change of. And so our function here, let's see if I can write on it. I can't write on it. So let me put this on a other screen. Okay, so I had to move the problem over here, but let's first try to find the slope of the secant line. And so we want to use this point, and we want to choose a point that's really close to this. And so let's choose the point close to 2, -4 to be x equals, how about 2 plus h? And we're going to try to make this h in a minute go down to 0. And so if we let x equal 2 plus h, and let's say this is our f of x function, right? We want to figure out what y is when x is 2 plus h. So we want to look at what is f of x 2 plus h. So we want to go in here to this function, wherever we see an x, we're going to replace it with 2 plus h. So parentheses squared minus 2 parentheses minus 4. So let me just simplify this. So if we distributed out 2 plus h times 2 plus h and we just FOILed through, that would give us 4 plus 4h plus h squared. Now let's distribute that -2 to that quantity 2 plus h. We get -4 minus 2h. And let's bring down the minus 4. So if we simplify this, 4 minus 4 cancels, but we also have another -4, so this is a -4. 4h minus 2h, so plus 2h plus h squared. I probably should have done descending order powers, but it really doesn't matter the order. Okay, so basically this is saying I have a point, right? When x is 2 plus h, my y value is h squared plus 2h minus 4. So we're finding the slope between these 2 points. And so recall, it's the change in our y value. So this is our f of 2 plus h, which I'll write down in a minute, minus our y value here, which is f of 2, all over the x value, so 2 plus h minus 2. Kind of look familiar? Notice the h's cancel, or the 2's cancel in the denominator, leaving us with just an h. And we already did this work over here. This f of 2 plus h, we found to be this h squared plus 2h minus 4, all minus f of 2. Well, we know what y is when x is 2. We know it's 4, so minus 4. Did I forget to distribute? Okay. I feel like I missed something. Oh, this is a -4 here. There it is. This is a -4. So this should be a +4. And so here our 4's cancel. Notice then we have h squared plus h, all over h. We can factor out that h. So we got h plus 1 all times h all over h, and the h's cancel. And so we're left with h plus 1. Well, we want to choose points that are really, really close to this point 2, -4 on the graph. And remember, we're choosing values of h that were going to 0, so that we got really close to that point. And so if we look at this now as a limit, as h approaches 0 of the slope of the secant line, h plus 1, this gives us back direct substitution is equal to 1. So the slope of that secant line is 1. But it also ends up being, because we let h go to 0, the slope of our tangent line. And so the next part of that question was saying, okay, now find the equation of the tangent line at this point 2, -4. So we found that the slope was +1. And we are given what point we want the equation of the line at, which was 2, -4. So I think my math lab will take it in either form, slope-intercept form or slope point or point slope form. I tend to like y equals mx plus b. It's just easier to graph. We can plug in our point, our m, and solve for b, and then we have the equation. So y is -4 is equal to our slope 1 all times x, which is 2 plus b. Isolate b. So we have -4 minus this 1 times 2. So -4 minus 2, b we get back as -6. If b is -6 and our slope is 1, then we know our equation of the line is y equals m, so 1 times x plus b, so -6. So this is the equation of the tangent line.
Wait, so which one was the slope?
It's 1. So basically, because we were choosing a point, and I don't know what this graph looks like. I know it's a parabola. So we were looking at what was happening at 2. But we were choosing another point close to x equals 2. It's probably facing upwards. And so basically, we're just choosing some other point close to 2, and we just called it 2 plus h. But when we let that value of h go to 0, we are basically getting that instantaneous rate of change at that term.
Okay, but we didn't solve for the 2.
Well, basically, they gave us the y value, and x was 2 in here with a point. Is that what you're saying?
No, because I had a similar problem, and the answer I got was something different.
You should have an equation of the line, and you should have a slope. Was your slope in terms of h? Is that what you're saying?
No, so my slope was 2. It wasn't 1.
Okay. Oh, but that's because you had a different equation and you had a different point, right?
No,
So
it was the same exact equation.
oh,
It was
really?
the same exact one. Yeah, so it was find the slope of the curve y equals x squared minus 2x minus 4, and the point was 2 and -4.
Okay, hold on. Let me just pause the recording and let me look for my mistake. And I see some chats coming through. Okay, so I made a mistake when I came back down and I was transposing what this y value was for when x was 2 plus h. I forgot to put this 2 in here next to this h, and so that's why we are a little off on the answer. So if I go in here, this was actually a 2h. This is going to kind of change. Let me just kind of erase from this point. It just makes my life easier. Thank you for catching that error. I'm glad you got the exact same one I got. Okay, So I'm going to come back down. I'm going to plug in, instead of that H there, it's a 2H. Oh, come on. Okay, so this was a plus 2H here, minus 4. And so when I bring this down, again, my 4's cancel, and I can pull out an H here. So this will be H all times that quantity H plus 2 all over H. And so the H's cancel, and so we're left with H plus 2. And so now this is where, when we're looking at the limit, as H is approaching 0, because we want that distance between those 2 points to be really close, of H plus 2, we get back 2. And so actually the slope was 2. So same kind of process of finding the equation line. You have a slope 2, we have a point 2, -4. We can plug those values into y equals mx plus b and solve for b. So if we do that, we get -4 is equal to our slope, which is 2, times x, which is 2, plus b. So -4 equals 4 plus b. Subtract 4 on both sides, b is -8. And so now we have the equation of the line, which is y is equal to our slope, 2x plus b, so -8. Okay. So I have a benefit in being the instructor. I have eyes on me when I'm doing the problem, so it's helpful because you guys can sometimes catch the errors. Unfortunately, you don't have people doing that while you're doing your homework or something. So some little error like that definitely screws up your answer until my math lab starts screaming at you, right? Okay, so we're going to stop here. We're pretty much done with 2.2. There's one other thing I need to cover really quick, but we're not really going to use it much, which is the sandwich theorem. And I'm going to skip 2.3. I'm going to probably move it another week out. I'm going to go into 2.4 first. 2.3 is just kind of really abstract, and so I just want to wait a little bit so we are more comfortable with what's going on in the terminology, and then we'll get into that formal definition of limits.